So this is a video part 1 of Math 290. So day 5, we're going to look at probability, statistics, and discrete math, which is a section of your praxis, also a section of your middle school math. You'll look at statistics and probability in grades 6 and 7th and 8th grade. So we'll look at the first page here, interpreting data. Well, tables, they could be vertical tables, they could be horizontal tables, are convenient ways to show data. Often the data presented in 2 columns, with the item being measured in 1 column and the percentage in another column. All right, for example, we might have where we've surveyed students and they tell us how many what's the number of pets that they own. And this is a good way to organize the data. It shows every person. However, we could represent this in a different way that would be a little bit more useful, which would give us the number of pets and how many students have a certain number of pets. This would also help us to have a total. So we would see we've got 8 and 6, that's 14, plus 1, that would give us, so we've got 15 students that own 0 pets to more than 5 pets. Now, the following facts can be seen in such a table, but not so easily from that original data presentation that we had, where we had just, and it looked just like this, where we had the student versus how many pets. So here, we could actually determine a percentage. We could also look at, well, how many have 2 or fewer, how many have no pets, or how many have more than 5. But in order to do that, we needed to have that total. So if we were going to create something with percentages, we needed to know a total amount. So going back to our original, the page before, how many students have 2 or fewer pets? Well, if they have 2 or fewer, we're looking at this section right here. And so we would look at this number, and so that would be 12. So 12 students have 2 or fewer pets. What fraction of the students have no pets? Well, we've got 0 pets. We've got 5 students. How many students have more than 5 pets? So we can see those that have more than 5 be right here, and that would represent 0. Taking all of the values from this table right here, we could figure out percentages. 5 out of 15. Say 5 out of 15, 3 out of 15, 4 out of 15, 2 out of 15. This would be 0 out of 15, 1 out of 15, and 0 out of 15. So we can figure out percentages. And so that's what you see in this column, is just how we've changed the number, how many students, into the percentages. But in order to do that, we needed to find a total amount. We think of bar graphs and histograms. Sometimes they kind of run together, and when you're thinking of the visual of what they look like, you might think, well, they both have columns, okay? But they are different. And bar graphs and histograms, they convey information using rectangular bars. Bar graphs, they're used when we're talking about categorical data. If we're talking about a person, or if we're talking about a thing, or if we're talking about an object, and we want to figure out how many or what's the frequency, where histograms show quantitative, or we could even say continuous. I can spell that correctly. We've got continuous data. So this example, we've got a bar graph. Notice that you do have some spaces. Sometimes people say, well, bar graphs have the spaces in between. And that is true, because if you look at what they're measuring, okay, tomato, pepper, onion, pepperoni, bacon, mushroom, this is what you would call categorical data. And so we can figure out things. So here we see tomato, there's 50. This is your number of votes, okay? Pepperoni, there's 100 and looks like 125. Onions, there's 200. Pepperoni, there would be 325. Bacon, we would see 150. And mushroom, we would see 250. So how many more votes are there for mushroom? Well, that's going to be 250. Take away pepper, which is 125. So there's 125 more for mushroom than there is pepper. We look at part B. There's two other toppings that combined have the same as pepperoni. Well, we got to look at what pepperoni is. Pepperoni is 325. So what are two others that when you add them together, they combine to be the same as pepperoni? And it looks like pepper, because pepper has 125, and it looks like onion, which has 200. So 200 plus the 125 is going to give you 325. Look at a double bar graph. Shows the same type of data for two groups. And this is on the same graph. These graphs use two different colors just so that you can see the differences. On a side note, this is a great thing to do in your classes if you are creating pre-tests and post-tests. You could always give students a pre-test to see what they know. I would encourage it to not be multiple choice. It would be able to see what they know going into it, and then have the same type of test as a post-test. Now, if you choose to have multiple choice on the pre-test, just understand that they could guess and get it correct, but not understand what they're doing. So I like to always make my pre and post-test open-ended. So it gives them a chance to answer things and get it wrong on the pre-test, but then after their learning, after their activities, after their formative assessments and whatnot, then you can give them a post-test. And this is easy to do in Excel. And then you have each of your students, and then you would have your scores. So you could have orange could be, let's say, a pre-test, and in green, you would have your post-test. One of the best teacher conferences I ever had at one point moving forward was I started showing how I was organizing my data. So all the data that I was taking in class, pre-test, quizzes, post-test, I was charting everything. So when I met with parents at conferences, I was able to pull up their data in a module of study and show them, hey, here's what they got on the pre-test, here's what they got on the post, look at the growth they made. We can also look at the quizzes or possible homework in between and how they scored, so a parent got a really good snapshot. One way to do that is a double bar graph. It's a wonderful way to show your data. And then you've got your stacked double bar chart. So just different different ways to visualize and represent data, and a good way to do this in your own classroom. Histograms. Now, like I said, they are used to display the data in what we'll say is a range of data. So if you notice here, the number of balls made, well, 0 to 3, 4 to 7, 8 to 11, 12 to 15. This is what we call a range. This is continuous because I could have, now the number of balls, you're not going to have really 1.5 of the balls made. However, if you had something that was in a measurement, something that could be, it could be time in seconds or in minutes, it could be distances. Those types of measurements are continuous, which would allow you to have 2.5 or 3.25 or whatnot, as long as it falls within a certain range. So how many more games had 12 to 15 balls made than 4 to 7 made? Well, if you look at your number of games over here on the left, we can see that that is a frequency. So there were 8 games where there was 12 to 15 balls made. There was 5 games where there was 8 to 11, and there was 1 game where there was 4 to 7, and you see there's 0 games where there's only 0 to 3. So how many more games had 12 to 15 than 4 to 7? Well, that's 8, take away 1. Your answer would be there's 7 games. So the following data points represent how many houses Greg, the garbage man, visited each day last week. So if we looked at I wanted to create a histogram. If I'm looking at, I've got from, looks like, if I go ahead and put these in order, so I've got 9, 12, 14, and I've got 23, 28, 33, 37. So I would say I could make my range, as I did down here, from 0 to 40. So what I'm going to have is, I'm just going to create another chart. And I'm going to say from 0 to 10, how many were there? Well, there was just 1. How many from 10 to, well, it was really 0 to 9, and then 10 to 20. And it looks like that there's 1, 2 of those. And then the 20 to 30 range, I've got 2. And then the 30 to 40 range, I've got 2. So therefore, when you look at scoring that, or putting into a histogram, 0 to 10, I will just make my bar. And then the 10 to 20, I notice I have 2. 20 to 30, I have 2. And then 30 to 40, I would have 2. So here's what the histogram would look like. The idea, take your data, figure out how many, in Excel, we typically call these bins. Figure out how many bins you need. And notice I made my ranges in increments of 10. So I looked at my data from 9, so from 0 to 40, groups of 10, and then I just charted how many in that least to greatest, as I put them in least to greatest, how many would fall in between. And that's what I put in my chart here, just to help me organize it so I can then put it into the graph. When we think about stem and leaf plots, okay, this is also quantitative data that can be presented as a table or as a histogram. Another way to represent quantitative data is use of this stem and leaf plots. Stem and leaf is represented in two columns. All right, the stem, which you'll see is going to appear on the left. This is one way to do this, is use it on the left hand. And it contains the values except for the last digit. That's if you are working with two place values, if you're dealing with ones and tens. The leaf, which will appear in the right column. So I want to create a stem and leaf. And notice the numbers that I have here, they're not in numerical order. So if I've got 12, and then I'm going to have 14 and 17. So I've got those that have that are in the tens place, okay? A 1 in the tens place. So I'm going to put a 1 representing the tens place, but I'm also going to have 2, 4, and 7. So this 2 here represents 12, this 4 represents 14, this 7 represents 17. So if I use a stem of in the 20s, so 2 tens, and then I'm going to see I've got a 20, but that's the only one. So I have to put a 0 here to represent that 20. And then the 30s, so 3 tens. So I'm looking at 1, 2, 3, 4. So I should see 33, 37, 38, 38. And just notice how I'm trying to just maybe do the best I can to line up everything. And then number 4, what do I have in the 40s? Looks like I have 43 and 46. So this would represent a stem and a leaf plot. And then if you're working on your paper, what you can see as well is if you have everything scaled correctly, you can draw your rectangular bars around and show that if you rotated it, you would see a histogram. And we are actually using increments of tens. So the first stem is really from 10 to 19. The next one is 20 to 29. The other one is 30 to 39. And the other one's 40 to 49. Let's look at number 7. A statistician for a chain of department stores created the following stem and leaf plot showing the number of pairs of glasses for each store. How many department stores have fewer than 38 pairs of glasses? So we're looking at fewer than 38. So that would mean 9, 13, 16, 16, 18, 21, 22, 23, 25, 26, 29, 30. And then see the next jump is to 41. Well, we wanted fewer than 38 pairs. So there's 12 because this is 1 and this is 4 and this is 6 and this is 1. So 10, 11, we would have 12. And then I'd already mentioned that stem and leaf plots are very similar to histograms. You rotate that stem and leaf. So if this is the original stem and leaf that we're looking at, if you rotated it, now we're looking at and this is what we would have. Kind of keeping everything on the same scale. And so that would represent our histogram, just knowing that down here we've got our ranges. So from 0 to 9, from 0 to 9, from 10 to 19, from 20 to 29, 30 to 39, 40 to 49 would represent that rotated stem and leaf. All right, so then we've got an example. We've got 20 test scores that were recorded for a math test. So if we put everything, if we listed everything in order, I would encourage you to pause the video and go ahead and put everything in order. Now, after you've placed all the test scores in order, you would see that the test scores range from 60 to 69. Well, there's one of them. And then 70 to 79, you'll find there's 6 of them. 80 to 89, there's 8. 90 to 99, there's 4. And 100 to 109, there's 1. So this is our table that we can use. We can, since we have a table, we can then go to, we could go to a stem and leaf, and then we'll go to the histogram. So if the stem is 6, representing the 60s, well, there's 1, and it's 69. There was one value, and it was 69. And then using the stem of the 70s, so 70 to 79, there's 6 of them. So 75, 75, 77, 78, 78, 79. In the 80s, 83, 84, 85, 85, 87, 88, 88, 89. In the 90s, we've got 97, 99, 99, 99. And then we have, notice I'm going to put a 10 there to represent the stem. There's 10 tens and 100, so 10 is the stem. And we would put a 0 there because it would represent the 100. So along here, I'm just going to label, well, this is the number of students. These would be test scores. And I'm going to kind of break the graph a little bit and show from here to here would represent 60 to 69, 70 to 79, 80 to 89, 90 to 99, and 100 to 109. Then over here, we're just going to put our scale 1, 2, 3, 4, 5, 6, 7, 8, 9. And so we would see from 60 to 69, there was 1. From 70 to 79, there's 6 of them. So 1, 2, 3, 4, 5, 6. '80 to '89, there's 8. '90 to '99, there's 4. And 100 to 109, there was actually 1 of them. Very similar to the 60 to 69. So there would be your histogram after we conducted our stem and leaf, which was after we conducted our table of data to organize everything. I think this will be the last part of video part 1 of our probability statistics and discrete math. So we're going to end with pie charts. And pie chart gets its name because it displays data as a wedge in a circular pie. Pie charts are also known as circle graphs. And pie charts are useful similar to bar graphs, categorical data. So you see everything over here in this example with social media engagement is all categorical. So here's Twitter, Facebook, there's Pinterest, LinkedIn. So I'm just labeling everything. And so once we have everything, we can see that, well, we're looking at percentages that represent. Now we need to know if we're going to get percentages, it means we had to know some totals. So with that, we know that there's 200,000 people that live in Arkansas. How many people are engaged with Facebook? Well, remember, Facebook is 27 7/10. So we could say, well, 27 7/10 out of 100 is equal to whatever out of 200,000. So we've got a proportion where we can do cross products, and that would give us 55,400 people are engaged with Facebook. How many are engaged with Twitter? Well, we would do the same thing. We'd say X divided by 200,000, and then just figure out what's the ratio that involves Twitter. And that's going to be 17 out of 100, so it's at 17%. We've looked at Facebook, we've looked at Twitter. Do our cross products, 200,000 times 17 divided by 100, and we would get 34,000 number of people that are engaged in Twitter. And how many are engaged in Pinterest? So here's our Pinterest. So we would say 10 6/10 divided by 100 is equal to X divided by 200,000. Do our cross products, and we would see that there's 21,200 people engaged in Pinterest. So that's, again, that's 10 6/10 multiplied by 200,000, divide that by 100. So with the pie charts, definitely want to know what your totals are. If you know your totals, you can create a percentage. And if you know your totals and you know your percentage and you wanted to know, well, how many out of the total represent these percentages, you can definitely use proportion to figure that out. So that concludes part 1 of this video series with probability statistics and discrete math.